This is Geometry, Lesson 12. This is our second day talking about arc length and area of sectors. So what we're going to talk about is circle D. We know that angle EDF is congruent to angle FDG, so these are both 80 degrees. So we're going to find the length of GF. Now for our reminder, we take the central angle over 360 is going to equal the length of arc GF over the circumference. Remember, arc length is just part of a circumference. It's not part of an area. So that's why it's over 2 pi r. So we have area as our central angle over 360 equals the arc length over 2 pi times 7 because our radius is 7. We would cross multiply. That'll give us 80 times 14 pi divided by 360. That's going to give us our arc length. So we take our triangle and we say 80 times 14 pi. We could look at that number and divide it by 360. That gives us a 9.77. That's our arc length is 9.77, and these would be in meters. Next, we're going to find the sector area of EDF. Well, this EDF has the same angle value. Central angle is 80. So again, our formula is going to be angle over 360 equals the sector EDF over pi r squared. So we know that they're congruent, so it's 80 degrees. We're looking for the area of the sector. Pi 7 squared. So that's 80 times 49 pi over 360. That is the area of the sector of EDF. So we're going to take 80 times 7 squared, which is 49 times pi, and we can divide that by 360. So the area is going to be 34.21, and those are meters squared because we always do area in squares. That would be the number of squares in here. It's amazing it's so many, but when the radius is 7 and it's an 80-degree angle. Next, we're going to find the measure of arc AB. Well, here, this would be our measure. When we talk about measure, we're referring to the angle value. So essentially, we want to know what our central angle is going to be. That's the measure of the arc. So the formula we use is the angle over 360, that's the angle we're looking for, over the arc length over the circumference, 2 pi r. So we don't know what the measure of AB is, arc AB, but it's over 360. We know the arc length, they've given it to us, is 2388. Can't have two unknowns. And 2 times pi times 12. So actually we're going to leave that one there, but we'll cross multiply this direction. So the measure of AB is going to be 360 times 23.88 divided by 2 times 12, which is 24 pi. So we take our 360 times 2388 and we divide that. We have to use parentheses, 24 pi. That gives us 114.02. Remember, that is an angle value, 114.02 degrees. What is the sector of ACB? So that's this gigantic pizza slice. What is the area of this pizza slice? So we take the area over, the angle over 360 equals the sector ACB over pi r squared. So we now know what the angle is. We're going to use that. 114.02 over our 360 equals the area of the sector ACB over pi 12 squared. So when we cross multiply, we get 114.02 times 144 pi over our 360. That equals the sector ACB. So we'll take our calculations of 114.02 times 144 pi, and we're dividing that by 360 at 143.28. And those are inches squared. That is the area of the sector ACB. Okay, for our next one, we're looking for the radius. We know what the angle is, we know what the arc measure is, we're looking for the radius. So, a radius has to do with circumference, so we're going to use the arc formula. So this is the arc length over 2 pi r. If we're going to find radius, we're going to use our formula with r. So we know it's 55 degrees over 360 equals our arc length over 2 pi r. And r is what we're obviously trying to solve for. So we do have to bring it to the top of the fraction. So that's 55 times 2 pi times r equals 360 times 19.71. So this here is going to be 110 pi times r, and this is 1971 times 360, which is 1095. 0.6. So we can divide by 110 pi. That crosses all of those out. So our radius, now when we divide this, we need to be sure that we use parentheses, that it calculates it correctly. We get 20.53. That's our radius, so this would be centimeters. So we're using the same formula we have all the way through, just re-plugging in the values that we have, trying to decide which of the two formulas. Do we use the sector formula? Do we use the arc length formula? Those are the two options we have. The area of the sector. So we want to know what the area of this is. So we'll use the area format. So that's the angle over 360. It's always that. And then we have sector area, and we'll put in HGJ. Now, what is that supposed to be under? When we're talking about the area, we're going to have the area of the circle. So we have a 55-degree angle. We are looking for the sector area. We're trying to calculate that. The radius, we have already calculated that as 20.53, and we'll square that. So we're going to multiply these two together. So we get 55. Now there's my radius. We'll just take the 20.53 and we'll square that. That gives us 421.48 times pi, and that should be divided by, no need to bring the 360 up to the sector because we needed area of the sector by itself. So we'll keep that down there. This is sector HJG. So we have our number, our squared, times pi times 55, and we divide that by 360. 202.296. So the 6 makes the 9 a 10, which makes the 2 a 3. So 202.30. This is area, so it's going to be centimeters squared. Here's the flip side. We've done this type of problem before. We're going to find the perimeter. So we know that this semicircle, which is half the circle would keep going, has a radius of 5. The diameter would be 10. This is going to be 10, this would be 10, this would be 10. The question is, what is the semicircle? So we're looking and talking about the circumference. The circumference equals 2 pi r. So the circumference of this circle is going to be 2 times pi times 5. So it's 10 pi, and that's if it went all the way around. But we don't really need this portion of it. So we need to take half of that, so that's only 5 pi. Now we're going to take the 5 pi plus the 10, 10, 10, which is 30. That would be your exact answer, because you can't group those like terms together, or those terms together, because they're not like terms. And that comes out to 45.71. Okay, for our second one here, find the area of the shaded region. Think about what needs to be done. You want the shaded region. It's this funny shape. That's not a shape that we know of with kind of this W going through it. But these are circles and a big rectangle. So we're going to take the rectangle area and subtract 2 times the circle area. So if this is 8 all the way across, this is going to be 4, and this is going to be 4. That means the radius is half of the 4. The radius is 2. So the area of the rectangle is 8 by 6. And the area of the circle is 2 of them, pi 2 squared. So this is 48 minus 2 times 4 pi. That's 48 minus 8 pi. You cannot call that 40 pi. This is a different, because they're multiplying, you cannot just subtract out the 8. So 48 minus 8 pi. And we get 22.87. Those would be units squared, square units. Okay, we move over here to the donut. We've done this donut one before. We got a different number up here, I believe. But we just want this donut section. We don't want the full circle. We don't want the inside circle. We just want this outside. 9 is to the edge, and 3.5 is the additional amount. That's a small circle with 9. So we're going to say large area minus small area. And we're referring to the circle. So the large area is pi times 9 plus 3.5. And we're going to square that radius. That's a radius all the way to the edge. And that's going to be 12.5. And we're going to subtract the small circle, which is pi times 9 squared. So we have pi times 12.5 squared minus pi times 81. Well, 12.5 squared is 156.25. And we're subtracting 81 pi. That we can. Those are like terms. They both, that should have a pi in it. They both have pi in it. Makes me hungry. So we have 156. 156.25 pi. Well, let's not say pi yet. 156.25 minus 81 gives us 75.25 pi. That's your exact answer. So if we times this by pi, we're going to get 236.40. And these are meters squared. That would be the shaded region. We took the big circle minus the small circle. All right. We'll come over here to our last shape. We're talking about a walkway that surrounds a fountain. So here we've got .30, we come all the way here to the edge. So we have this rectangle, and then we have a big circle, and we have a small circle. So we're going to have to take and subtract this circle from this bigger circle, but we don't want to double dip this part. It's going to get interesting. Alright, so let's see what we have. We have a rectangle, full rectangle, minus, this is a radius of 9. So we have a full rectangle minus a circle, half the circle is what we have. So we're going to do that one first. We have a rectangle area minus half circle area, which is the fountain. So we have 30 times 42.5. That would shade in everything here in the rectangle, but we don't want to shade in this portion where it has a radius of 9. So that's half the circle. Half pi r squared. So that's going to be 30 times 42.5, and we're subtracting 0.5, which is half, times pi times 9 squared. Now, order of operations is pretty confident it's going to do that with this. It's going to take the rectangle and minus the whole piece. Order of operations says you'll do multiplication before you do the subtraction. I'll show you that it comes out to be the same. I put parentheses around what we're subtracting just to be safe. Right? It's like subtracting this whole part, which makes sense. We have to be careful about what we're calculating. But I got 1,147.77, and those are feet squared, or square feet. Now we could try that again. Look at your whole equation and get rid of these two parentheses, and I'm pretty sure we're going to get the same answer. It's because multiplication comes before subtraction. But just to be safe, parentheses are a good idea. Now we have this other half to do. We have this big circle that has a radius of 15, and we have to subtract the small circle with a radius of 9, but we only want half of it. So we want half of pi 15 squared minus pi 9 squared. We only want half that amount. So we're going to take 0.5, take half of pi times 15 squared minus pi times 9 squared. And again, we don't have to worry about how we're subtracting this because it's multiplication. We get 226. 226.19, and these are feet squared, or square feet. So now we add those two numbers together. And when we add, we're going to get 1373.96 square feet. Whew. Next, we could talk about the probability. That'll be fine. All right, last one. A small fence needs to be built to keep the rabbits off the walkway. How much fencing is needed? So we just want to do the fencing around the edge, so the fountain really has nothing to do with it. We have 30 down this side, 42.5 to get to here. Then we have to do our semicircle, and then the 42.5 on that side. So let's figure out what our circumference is, and we want to take half of our circumference. We could get fancy and use the arc formula, but since we know that the angle is exactly half, we can just take half of it. So the circumference of our circle is going to be 2 pi r. So that's 2 pi times 15. So that's 30 pi. And when we calculate what 30 pi is, that's approximately 94.25. And those are feet. But we need to take half of that. So I'm going to divide by 2, and we get 47/12. That's the amount that this gives us. 47/12 is the curve part. Now we have to add the two 42s and the 30. So we'll add 42.5. We'll do that twice, not squared, but times 2. And we'll add 30 to that. So we're going to take our answer and add 2 times 42.5 and add the 30. Gives us 162.12. Those are feet. Think about what we just did. We had to find the perimeter around the circle. That would go all the way around the circle. That was 47. But we only needed half the circle. Actually, the whole circle was 94. Half the circle was 47. Then we added the 42.5, the 42.5, and the 30. Good job, everybody.